Hello, we are going to do in this video our notes for 19.3, which in our quadratics station unit is station 4, and it's interpreting vertex form and standard form of quadratics. Also to warn you, I'm trying to use my home desktop so it doesn't get that kind of weird sound. I'm hoping that that's better than my laptop that gets a kind of funny sound to it, but I also don't have a touch screen to write with, so now I'm going to be writing with a mouse or trying to type in the blanks here, so it might be a little bit crazy that way. So in this case, the first part of this is talking about determine whether a function is a quadratic or not by looking at, what we're going to do is, just like we've been talking a lot of the times, is that we're going to be looking at the graph. Okay. Because we know we have that handy dandy tool, that option to pull up Desmos. So we can look to see if something on the graph, okay, so is a quadratic. In this case, when if the graph is a parabola, okay, remember from the first two stations when we introduced the characteristics, okay, which is a U-shaped, okay, on my graph, then the function is a quadratic. If I don't have a U-shape, if I don't have a parabola, then it's not quadratic. We have done several others. The main type of function that we talked about at the beginning of fourth quarter, or I'm sorry, at the beginning of first semester, most of all of first semester, was linear or a line. We also did some exponentials where it became that. Okay, so we had graphs that were lines, we had graphs that did that curve shape, those were our exponentials that we did earlier this chapter. And then we have now here our parabolas. So those are kind of the three types of functions that we have dealt with. So in this case, if I give you some examples here, so our first example is on this slide, determine whether each function is a quadratic function. Again, as we've done a lot of the time, if I give you this equation, f of x equals x plus 4, I want to see what it looks like. I want to see what the graph looks like. And then hopefully you'll get into a pattern where you're able to notice the difference between, oh, wait, I can just look at the equation and know that that's linear, or I can look at that equation and know that it's a quadratic or an exponential. So in this case, if I go ahead and pull up our Desmos here, I'm going to try to do a little bit of split screen so we can see it a little better. I want to determine if it's a function. So we're going to put in our f of x equals x plus 4. And you'll notice what came up if I look at just the graph part of this. Oh, it's a line. Even if I zoom out, making sure I'm seeing all the graph, it continues to be just a line. So in this case, when it says determine whether the function is linear, or I'm sorry, is a quadratic function, in this case, this is not quadratic, but it happens to be a linear function, meaning it's a line. Okay. So now we're going to look at the next one. X squared, f of x equals x squared plus 2x minus 6. And if again I pull up Desmos, I'm going to type that equation in here. F of x squared plus 2x minus 6. Now we see our U-shaped graph, and therefore, in this case, our U-shaped graph is a quadratic. So yes, this one is a quadratic. Now, think about it for a minute. What we've been talking about what part of that equation, and you hopefully saw it as I was typing it in. As I was typing in our equation here, as soon as I typed in the x squared, then you could see a parabola. You could see that U-shaped graph. Now it changed a little when I entered the rest of it, the 2x minus 6. But as soon as I see that x squared in my graph, I know it's going to be quadratic. So now let's try the next one. F of x equals 2 to the x power. So in this case, we see that curve. Right? We see that curve and it goes down towards the y-axis, but it's not going back up so that I get that U shape, that symmetry. And so in this case, this one is not quadratic, but it happens to be exponential. And I know the directions don't say what type is it, but just again, as we're coming up on the state test, as we are getting here closer and closer to the to the end of the quadratics unit, being able to recognize linear versus quadratic versus exponential is a big part of Algebra 1. And here's the reason in this case this one is an exponential, is because my variable, my x, is the exponent. So that's what makes it an exponential function. So let's try D. If you can look at D, and I have f of x equals negative parentheses x minus 3 squared plus 2. So hopefully take a minute and think about, or put it in Desmos and try it yourself. But in this case, if I look, oh wait, there's my exponent of 2. So if I go to put that in Desmos, my negative, my parenthesis, x minus 3, right now it looks like it's a line, but as soon as I put that exponent squared there, now it's changing to a parabola. And so that means, in this case, D, my example D, it is a quadratic because I get that U-shaped graph. And my last one, f of x equals the square root. So I'm going to have to pull up my keyboard here to find my square root. There it is down at the bottom next to the ABC, my square root of x. Oh, look at that. It's not a U, but it looks like it's a little curve that just kind of is not a line, it's just curved one out to the side. So in this case, this one is not a quadratic. It's actually not linear or exponential. It's a different type. It's a square root function. You don't have to worry about that. But I do want you to notice that this one is not quadratic. So as a summary here, some kind of questions to think about and reflect on is that how can you determine whether a function is a quadratic or not by looking at its graph? Okay. And think about that to yourself. See if you can answer that, like I was asking the question in class and waiting for a response. In this case, see if you can come up with, if I was trying to determine how I can determine whether a function is quadratic or not by looking at its graph. In this case, I'm looking to see if the function does the function give us a U-shaped or parabola graph. Then it will be quadratic. That's how we can tell by the graph. But the other part of this question then is asking us, how can I tell if the function is quadratic by looking at the equation? So in this case, if I'm just trying to look at the equation, and I kind of try to help you here on B and D, the examples above, remember in this case, I'm looking to see, does the equation have an exponent of 2? And really I'm looking to see, does it have the highest exponent of 2? When you get into Algebra 3 or Algebra 2, you'll do some other functions where the highest exponent is 3 or 4. And those are not parabolas, but in this case for you guys, we're doing linear, quadratic, and exponential are really the functions we're focusing on. And therefore, if I have an exponent of 2, then that means it's going to be a quadratic function or give me that U-shaped graph. So I can look at just the equation and tell, is it a quadratic or not? So when I'm writing a quadratic function given a table of values, there's a couple things. I have shown you guys when in 19.2 in that lesson, we were talking about how equations were translated. How are they? And remember, translated just means moved. How were they moved? Were they moved left, right, up, or down? In that lesson. So in this case, vertex form is this form y equals a times x minus h squared plus k. That's vertex form of a quadratic. That's very, very important. So I'd highlight it. I would put a star next to these two boxes. These are two very important equations that you're going to need to know. Standard form is, again, you've seen this when I first started introducing quadratics in 19.1 when I taught that lesson as a class. Y equals a x squared plus bx plus c. And that's our standard form of a function. So in this case, if they give us a table of values, they give us a table, and we want to write the quadratic function in vertex form or standard form. We're going to use our best friend here. I'm given a table, so remember, I'm going to clear out my equations that I did earlier, how we get a table. Remember, some of you are going straight here to the wheel, the gear, and then you're trying to find table here. Remember, if you can't find table, that's when I give you an equation and when we pull up the table. But if I can't find it here, remember you also have the option for the plus sign to pull up the table there. So in this case, I'm going to enter my table, -6, 9, -4, 1, -3, 0, -2, 1, and 0, 9. Okay, now I'm way zoomed out, and actually I'm going to go back here to our home, and that'll put me back closer to, and I can see my points. Now, you can already tell because of those 5 points do make that U-shaped graph. And so in this case, though, the directions wanted us to write the equation in vertex form and standard form. And in this case, then, that's where these two equations are going to come in handy. And we've done this idea with exponentials. We've done it with linear when we were then typing in. So instead of just putting in this exact equation, that's when I'm going to put in my sub 1. And instead of an equal sign, that's when I'm going to put in that fancy tilde. So in this case, I'm going to put in my y sub 1, my tilde. I'm going to put in my a parentheses x sub 1 minus h parentheses squared, and then I'm going to put in my plus k. And so you'll notice that when I do that down here at the bottom, that we get an a value, a k value, and a -3. Okay, so we actually get, see if it'll let me know. Okay, it's right here. Okay, this part of my function. Okay. So in that case, then those are my a. That's what I'm going to plug in here. So if you know this equation, now all I'm going to have to do is I'm going to write, okay, so for a, extend the page here so I can type this in here. My equation is y equals, now my a value was 1, so I'm just going to have y equals 1 parentheses x minus my h value was a -3. So minus a -3 squared, and then plus k, which is 0. Okay, now I would say that in this case, this is fine. It's acceptable, but remember, we don't usually like to leave negative in a problem like that. So really, we would really write this equation as y equals 1 parentheses x plus 3 parentheses, and then in this case, I'm going to put in my squared. And you can put in the plus 0. You don't have to, though, because anything plus 0 is just nothing there. Okay, so really, this is our equation of that parabola. And we did it, again, just by using my Desmos, or using our Desmos, our best friend here. And that's vertex form. Okay? So now, if we wanted standard form, we can do the same idea, but we just need this equation, this y equals ax squared plus bx plus c. But every place, again, there's a y, I'm going to do sub 1. Instead of my equals, I'm going to do tilde. And then ax, I'm still going to do my sub 1, but now I'm also going to do my squared. Kind of looks weird, the 2 up above and the 1 below, but to be honest, this is what's going to give us our equation. And so I'd get my bx sub 1, and then I would get my plus c. And you'll notice that when I do this, there's my equation, and then down below here, here's my a, right here, here's my b, and here's my c. So in this case, now all I have to do is take those values and I'm going to plug them in. Okay. So for standard form, I'm going to put standard form in red. Standard form would be y equals, let me pull this over here so I can see it at the same time I'm typing. I didn't want it that big. Is I would want here, my a value is 1, so it would be 1x squared plus my b value is 6, so 6x plus 9 is my c value. And I'm taking these values right here, a, b, and c, and I'm plugging them in to that standard form there in the box. So these two equations here are very, very, very important. If it were me, I would star them. I would do something to make sure that you realize that these equations are so, 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 so important. I'm trying to find my star. There's my star. Okay, these two equations are so important. And again, the important thing to remember, I'm going to try to write with the pen here, guys, is that the equal sign, I'm going to change. Instead of an equal in Desmos, I'm going to change to that tilde. And then remember, the y really is becoming y sub 1, and the x is really going to go into Desmos as x sub 1. So those are the only things. If you remember these, and then you remember the sub 1s for the x and y, and a tilde instead of the equal sign, you'll be made for writing these equations. So take a minute, try B on your own, change your table here, change these values, okay, clear these out, okay, and try them on your own. Try to remember what those values are. Go through and clear out these values, and try this one on your own. Take a minute, pause the video, try it, see what you get. Okay, so hopefully at this point you've tried it on your own, you got your equations. When I did that, I had to zoom out a little bit to get my points, but you can again see the parabola shaped there. And again, I'm going to type in, here's my equations. Use your notes there to help you until you get it down. Y tilde a, oops, I even forgot, a sub 1 tilde a parentheses x sub 1 minus h parentheses squared plus k. There's my a, h, and k. And then here for my standard form, y sub 1 tilde ax sub 1. I also want to square that, plus bx sub 1 plus c. And there's my a, b, and c for standard form. So if I was going to go write my two equations here for b, for vertex form, you should have gotten an answer of y equals -5 parentheses x minus a -2, but we see that negative negative, so that would change to +2 squared plus k, which is a -7, so I could just make this -7. And then if I want to do my standard form, I have my a, b, and c, so I would get y equals a is -5 x squared, oh, sorry, typed the wrong button, plus b, which is -20, so I'm going to do -20 x, and then minus c, which is negative 27. So my equation in standard form would be negative 5x squared minus 20x minus 27. Okay. And our last equation, our last section, is our lovely word problems. I know they're not our favorite, but these are how they're going to be set up on the test.
I'm gonna go watch my television.
Okay, so in this case then, the last two problems we have here are write an equation, writing the quadratic function given a graph. So they say on this first one, a house painter is standing on a ladder, drops a paintbrush. So the paintbrush is not going to just fall straight down. It's going to kind of take this parabola shape. Um, and the paintbrush height above the ground in feet is given by a function of the form a times x minus h squared plus, or where x is my time, so here's my time, and 8 or y is my height. So in this case, because if I just put in these 2 points in Desmos in our table, here we had 5 points and it did make that parabola shape. If I just try to put these 2 points in my table, it's going to think it's linear because I can draw a line through a straight, or I can draw a line through 2 points. So we're going to do kind of this a different way. We know since the paintbrush is dropping from this point up here, this point up here is my vertex. And if you remember from the Station 2 19.2 notes, is that this vertex is always, the vertex is always your H and then your K value. Always, always, always. So I know in this case that, I'll be honest guys, I think this one here should have a plus K in that equation. I'm sorry, there's a typo in that. Okay, so I know in this case for this problem that my H is 0 and my K is 25. I know that since I know that paintbrush is just at the top, that it's 0, 25. So I know that this is 0, I know my H is 0, and I know this is K value is 25. So when I go to write this, I think it's easier for me to type it in here so that you guys don't have to deal with my horrible writing with the mouse. This would be f of x is equal to, get this out of the way, my a value. That's what I don't know yet. And then I'm going to have x minus, my h value is 0, so that's squared. Just plugging in h and k. I'm plugging in the 0 and I'm plugging in the 25. Now, in this case, remember that f of x is just y. So I know right now I have y equals a. X minus 0 is just x. Anything minus 0 is just itself. So I really have here just x squared plus 25. But what I'm missing, what I don't know so far is I don't know what a is. And that's where this other point in the problem is going to come from, that 0.19. So I know after 1 second that paintbrush is 9 feet off the ground. Okay. So in this case, if I know that, then that tells me here that that 1 is an x value and that 9 is a y value. And so I'm going to plug those in for x and y, and if that's what I have, then I can solve for a, if that's the only variable I have left. So in this case, go back to my typing here, I would have 9 is equal to a, that's what I don't know, plugging in the 1 for the x squared plus 25. Gosh. Okay, and now I can solve this. So I just have 9 is equal to a, 1 squared is just 1, so that's 1 times 9. I'm sorry guys, my phone just vibrated and it kind of threw me off. 1 times a, and so then that's plus 25. And so really all I have to do now is, step back here and go back to my pen, is now, this is just 1a, or just a. So now I'm just subtracting 25 from both sides, and I would get, the 25s are going to cancel off, 9 minus 25 is going to give me a negative 16. So I get negative 16 is equal to 1a, or is just equal to a. So now that I have those values, now I can write my function again. So my answer is going to be, my final answer here would be y is equal to negative 16 x squared plus 25. And again, because it's negative, and again, this is from your 19.2 node, station 2, because it's way negative, we know that parabola is opening down. And that's really what happened. If we were to draw this other side of the parabola, it would look something like this. But this is negative time, and we know we can't drop that paintbrush back in negative time, so that's why we don't see that part of the parabola. But you can then see that U-shaped graph. Okay. And so here, a rock is knocked off a cliff into the water far below. Our second example here, the rock or the falling rock's height above the water in feet is given by a function of the form f of x is equal to a times x plus h squared plus k, where x is the time in seconds after the rock begins to fall. So again, I know because that's where the rock is starting up there at the top, that I know here this is my vertex. So once again, I know that the 0 is my h, and I know the 45 is my k. So if I know those two things, then I'm able to plug those back in. So f of x is equal to a, we don't know what a is, x, this was a typo again, guys, gosh, sorry, I must have been, this should have been all, it's always x minus h. It really is not going to matter in this case because we're plugging in 0, and then I have plus k, so I have plus 45. So if I simplify this again, f of x just means y, and I could have plugged that in from the very beginning. Y equals a times x minus 0 is just x squared plus 45. So hopefully at this point you got to this part, this makes sense to you. And so now all you're going to have to do is I would pause it, figure out how do I get what a is? Figure out what a is equal to. Okay, hopefully you've paused it and now you're back to check to see if you got the answer right. In this case, my x is 1 and my y is 29. So when I go back here to my equation, my typing here, I would now have 29 is equal to a. I don't know what that is, but I know this is my x squared. Oh, but I do know x. Remember, my x is 1. So 1 squared plus 45. So if I was to simplify this, 29 is equal to 1 squared is just 1. So this is 1 times a, or just 1a, plus 45. And now I can just subtract 45 from both sides. So when I do negative 45 minus 29, I would get negative 16 equals 1a, which remember, that is the same thing as just saying negative 16 is equal to a. And if I know that, now I can just take my equation and I have y is equal to 1a, or just 1, x minus 0, the whole thing squared, plus 45. Sorry guys, that was a typo. Plus 45. Again, if you didn't want it like that, the other way, because of the minus 0, this would also be acceptable if you did it as y equals 1 x squared, because x minus 0 is just x squared plus 45. And you know what? I was thinking back to this one. I'm sorry, guys. This would be negative 16 as your a value. So I'd actually get negative 16 x squared plus 45 is my final answer. Okay. If you have any questions, please, again, that's part of the station work, is making sure you take the time to stop, ask me questions, making sure you understand this before you move on to the homework. Okay, so that's the end of 19.3. Make sure you decide if you're going to do the HMH, if you're going to do a worksheet, or if you're going to do one of the extra practice activities. Okay, thanks guys.